Hi everyone. So today here we take the derivative of log functions. I gave you the derivative of exponential functions. So what is log here? So if you have y equal log base b of x like this. So that is your base, we call it base. B here it's a base, and that is also positive number. If you try to rewrite this as exponential functions, it will be b to the power y. B here, that is your base to the power raise. So you take your base raised to the power y equal whatever you have inside your log here, which is x. So b to the power y equivalent, that is equal to x. What is x? Whatever inside your log, right? So if you have b equal e, what is e? 2.7. 2.7, then your log here, log base e of x here, that is, it will write it ln of x, ln x here, or ln x here. That is the one that you have in your technology. If you look your technology, you have, and this one we call it natural log, natural log, right? Natural log. So that is the one that you have. If you turn out, that's the case number one. Case number two, if you have b equal 10, if you have b equal 10, then your log, your y here, we write it log, your b is 10 of x, and that is, we don't write anything. That is exactly like log x, and that is called common log, and that is the one that you have in your technology. You have log. So if you have log x, that is your base here is what? Is not 1, is 10. Your base here is what? Is 10. It's called common log. So our goal for today here is to take the derivative. What is the rule to take the derivative? So let me give you a general rule, just one equation, and then that is the one you should really know, and that is the one you should really use. I need to take the derivative d by dx, and here log base b, and here I have right f. So what is inside here? You have f. And what is your base here? Your base is b. I need to take the derivative of this, so you have log b of f here, and the whole thing I need to take the derivative of this. It turned out is nothing but is 1 over whatever inside here. What is inside of your log or f? And then I have to multiply that by ln b, your base, and the whole thing multiplied by f prime of x. What is f prime of x? The derivative whatever inside of your log, the derivative whatever inside your log. And then so you have 1 over f, again f whatever inside over it. So that is the rule, or that is the one we should really know, and that is called here the rule of your log, or that is the formula of log. And you can take a special case of all of this. For example, here special case 1 here, if it turn out b equal e, then what do you have here? If you have b equal e, then the formula here, it will be the derivative of your derivative with respect here. So log base e of your f here. So that is nothing but exactly log base e is what? Is ln your f. So what is the derivative of ln f? ln f. So if you try to apply this one rule here, it will be just go ahead and use this one here. Here is the formula, 1 over, what is inside here? OF, so you have 1 over f. ln, what is your base here, guys? What is your base? Your base is what? My base here is what? Is e. So you have ln e, right? And the whole thing multiplied by f prime. What is f prime? The derivative was whatever inside your log, or ln. So that is your f. So I have to multiply the whole thing by the derivative of f. Now, what is ln e? If we use technology, it's 1. So what is the derivative then? It will be 1 over f multiplied by f prime. 1 over f multiplied by f prime. That is the derivative of ln f, right? So that is another rule here as a special case. Indeed, if you know this one here, let me call it star, this one here, this one should be enough. And the other ones here, just if you apply this formula, then you can get easy 1 over f prime. All right, 1 over f prime. And then I'm going to give you some example before I solve the problem here. And then that's the sheet here. So I need to solve some problem. All right, so how? Example number one here, I need to solve this. If you have y equal ln x plus 5, All right, I need to get y prime. What is your y prime? I need to get y prime. All right, so what is given here? ln of x plus 5. So what is ln here? That is, if you want, you can write it log base e of x plus 5. Log base e, ln, it's nothing but log base e of x plus 5. I need to take the derivative of this. What is your f? Your f is what? X plus 5, that is my f. Whatever inside here, that is your f. What is your base? E. Your base here is e, so it will be 1 over, here is the rule, look what you have, 1 over f, 1 over f, so I should write 1 over f. What is 1 over f here? It will be 1 over x plus 5, right? ln e, so here, look what you have, ln f, here, that's the formula here, ln f is what? Is 1 over f prime, so x plus 5 prime, x plus 5 prime. Then what is the derivative of x here? So 1 over x plus 5, right? What is x? It will be x prime. What do you have in the middle plus? Then you take the derivative term by term. So the derivative of first term, what is that? X plus x prime. What is x prime? Is 1. X prime is 1. The derivative of x here with respect to x is 1. 5. What is the derivative of any constant? Should be 0. So here, that is give you 1. So that is our derivative. Just leave it like this. And that is, it will be our derivative, right? So now you have one property of log. If you are able to use, maybe I should write it here, property here, or law of log. So a kind of law or something like that. So you have seen that maybe in high school or math 1070, law of log. What is that? This one make our life easy before how to simplify before you take the, what is number 1? If you have log a multiplied by b, a multiplied by b, it will be log a plus log b. That is the first rule. If you have product, then you take the log of the first one plus log of the second one. Log second one rules here, a over b, then it will be log a minus log b, right? What is the third one? The third one here, that is the one I'm going to use. If you have log a to the power r, a to the power r, that is exponent, then you can take r, you put that in front, you can put it in front, it will be r here, r log a. Those three rules here make our life easy when I solve problems. For example, here, that is your r here. So that is your r here. So you have r, that is your r, the exponent, and then I put that in front of my log, and then you can have the so now let me give you extra problem, one example here. If you have y equal ln x minus 8 to the power negative 2, right? So now what is the question? Find dy by dx or y prime. Dy by dx or y prime is the same, right? Dy by dx or y prime, it will be the same. So now how to get dy by dx or y prime? So now just read the problem loud so that you can hear yourself. Oh, log here, bracket x minus 8 to the power negative 2. So here len or log means you have to take the derivative. You have to know the rule of what is the derivative of log. But also you have a bracket to the power n, a bracket to the power negative 2. That is power rules. So here I have to apply two rules, power rules and log rules. Log of the derivative log plus power rule, because you have a bracket to the power n. So now if I use this law of log here or property of log here, what do you have? Look what you have, number 3 here. This one, what is your r? Your r negative 2, your a here, that is a bracket. So you have a bracket to the power r, I can put r in front. So this one I can simplify before I take the derivative. Then what do you have? Negative 2, I put it in front here, that's negative 2, I put it in front. Then you have log here or ln x minus 8, so that is your y. So now I need to get y prime. Y prime means you take the derivative of the whole thing. You have to take the derivative of the whole thing here, the derivative of the whole thing, right? What do you have for negative 2? Negative 2 here, it's a constant. I can grab this negative 2 outside. So if you have negative 2 outside, so what do you have? You have x minus 8, and that is the derivative of this. right? I need to take the derivative. So now, if you have what is the derivative log, this one, if you want, you can apply the rule, which is 1 over f here. Look what you have. This rule here, 1 over f prime. 1 over f, that's 2 here, rule number 2. Derivative of ln f, it will be 1 over f prime. 1 over f prime, right? 1 over f prime. So because of that, I have to write, go back here. So you have -2, that's a constant. 1 over f, what is your f? X minus 8, multiply by f prime. So that is your f prime. So now what do you have in the middle? Minus. If you have in the middle minus, means you take the derivative term by term. Derivative of the first one, which is x prime, which is 1. What is the derivative of -8? 0. -8, that's a constant. Derivative any constant should be 0. So what did you get? -2 outside, divided by x minus 8. And the x minus 8 here is 1. X minus 8 here is 1. All right. So here, that is, you know, I'm not asking you to simplify or anything, just to take the derivative, just take it as, just apply the rule without simplify. Okay. So now I'm going to solve the following sheet here. So, and then okay, guys. So here, let us record here, solve some of this problem here. So if I solve the first one, b here, b, if you have y equal ln 5 to the power x, so what is your f? That is your f here. So what is the rule? The derivative of ln f is nothing but it will be 1 over f prime. 1 over f prime. So that is the rule I'm going to apply. So what is your f here? 5x. And the derivative of 5x here, it will be 5x prime. That is your y prime, right? So what is your f? Whatever inside here, that is my f, right? So it will be 1 over f prime. So now 5 multiplied by x, you can grab 5 outside. So what do you have left? X prime. It's a 5 multiplied by x, so you can grab 5 out. So what do you have? You have 5x. So what is x prime? Is 1. Very good. So you have 5x. 5 cancel with 5. You get 1 over x. You get 1 over x, right? So that is 1. So now if I look for d here, I want to distinguish between c and d. So c, if you look to c, you have y equal ln x to the power 5. So it's one log here, just one log, x to the power 5. So what is inside x to the power 5? So if you, what is the rules? What is your f? Your f, whatever inside here, that is my f. So y prime, it will be 1 over f, which is x to the power 5, multiplied by x5 prime. x5 prime, so that is f prime. X to the power 5 prime, so that's f prime. So if I simplify this, you have 5 x to the power 4 divided by x to the power 5, right? X to the power 5. So now if you want to simplify this, how to simplify this one here? In order to simplify this, recall here, right? If you have a to the power n over a to the power m, this one, it will be n minus m. So x to the power 4 and over x to the power 5. So I could simplify this to write here 5, that's a constant. But what do you have here? You have 4 over 5, right? So if you want, you can write it like this. It will be just 4 minus 5, which is 5 multiplied by x to the power -1, or just 5 over x. 5 over x, that is what you got out of this, our derivative. So that is correct. Some people say, I'm not going to simplify this. Let us use this law here. Look what you have up here. Where is the law here that I wrote here? I think I missed it here. So I could simplify this using number 3 here, this formula, log a to the power r, and then it will be very easy, right? So let me show you. If you have another solution here, some people, they say, well, I could, another solution. If you have y equal ln x to the power 5, ln x to the power 5, I can put 5 in front, so you have 5 ln x, 5 ln x, right? Then you go ahead and take the derivative of this. What is, how to get the derivative? So the derivative of this one here, just, you will have, just to try to, just if you get y prime, it will be y prime, it will be 5 ln x, the whole thing prime. right? So 5 is a constant. I can grab it outside. So what do you have inside ln x prime? So what is the derivative of ln x? It will be 5. Ln x, it will be 1 over x. What is your f? Your f here is x. 1 over x, 1 over f. F prime, which is x prime. What is x prime? X prime here, it will be 1. X prime is 1. So you have 5 over x. And that is our derivative, similar to this one here. If you do this one here, if you simplify before you take the derivative, then our life become very simple and easy, right? So now let me solve the other ones. D here, you have to distinguish between this one and D. You have y equal ln, that is written 5 of x like this, right? And this one is exactly like ln multiplied by itself. How many times? 5 times. So that's a bracket to the power 5. This one the same, but the other one is not the same. You have other one y ln x to the power 5, the x to the power 5. So here it's 1 log, just 1 log, but here it's a 5 log. So you have ln x multiplied by itself 5 times. So now you have a bracket to the power 1 to the power 5, a bracket to the power 5. Then I have to use power rules. I have to use here power rules. Whenever you have a bracket to the power n, here is the rule. If you have a bracket to the power n, that's power rules. Power rules here. You have a bracket. Inside the bracket you have f to the power n. I need to take the derivative of this. It will be n. Here is your bracket, n minus 1. The whole thing multiplied by f prime. What is f prime? F prime is the derivative whatever inside the bracket. The derivative whatever inside the bracket. So here, let us apply this here. So you have y prime. It will be ln x to the power 5. That's a bracket to the power 5. I need to take the derivative of this. Now, if I compare, what is my n? Your n is what? Your n is 5. What is your f? What is inside the bracket? F. What is inside the bracket? ln x. So what is the derivative? It will be 5. That is your n. And here is your bracket ln x 5 minus 1, n minus 1, n minus 1, and I have to multiply by the derivative whatever inside the bracket, the derivative whatever inside the bracket. So it will be ln x prime. Now you need to finish it. So you have here 5 ln x to the power 1 to the power 4. 5 minus 1 is 4. And what is the derivative of this? Here it will be 1 over x. What is your f inside x? You have multiplied by x prime. 1 over x multiplied by x prime. So 1 over f prime. So what is x prime? X prime is 1. X prime is 1. So what do you have? You have 5 ln x to the power 4. 5 ln x to the power 4 divided by x. Divided by x. And that is our derivative. So here, if you read loud here, so you can hear, oh, it's a bracket to the power 5. Bracket to the power 5 means power rules. Power rules, right? So I want you to distinguish between this term and this one. Here it's 1 log and x to the power 5. But here, the log multiplied by itself how many times? 5 times. All right, so you have a bracket to the power 5. All right, so that is, I solve one here. So maybe I think the other one here, it's a kind of quotient rule. Maybe I move to the other problem here where you have more problem here. So number 4 here, if I try to solve number 4, maybe I solve this problem here, b. It's easy. So let us solve b. What is your b? G of x equal 1 over ln 2x plus 5, right? So if you read that loud, 1 divided by ln 2x plus 5. So when you see divided by quotient rule, and you have log here, so you have quotient rule, and you have to apply also what is the formula of the derivative of ln, right? So now some people, they don't like quotient rules. They say, can I take, that's a bracket here, the whole thing, whatever I have down here, or ln 2x plus 5, that's a bracket to the power what? 1. Here recall, if you have 1 over a to the power n, I can take n up, become negative n. So what is the n here? Your n here is 1. So this one I can simplify as 2x plus 5 to the power negative 1. To the power negative 1. So you have a bracket to the power n. Now a bracket to the power n, which is you have to use power rules. Power rules, right? So a bracket to the power n, it's a power rule. So what is g prime? I need to take the derivative. So which is ln 2x plus 5 to the power negative 1. I have to take the derivative of the whole thing here. The derivative of the whole thing, that's prime here. I have to take the derivative of the whole thing. Then how to take the derivative of this? What is the power rule? That is your n, your exponent n. I put n in front. Here is your bracket. Where is the bracket? 2x plus 5 to the power what? N minus 1. Negative 1 minus 1. N minus 1. And I have to multiply by the derivative, whatever inside the bracket. The derivative, whatever inside the bracket. Right? What is inside the bracket? That is what is inside the bracket. So I have to take the derivative of whatever inside the bracket. That is called power rules, right? Then I have to finish this problem here. How to finish it? Negative 1. Here you have negative 1. You know, see, there is no writing here. So you have negative 1, right? And here ln 2x plus 5 to the power what? Negative 1 was negative 1. You have negative 1 minus 1. You have negative 2. Now, what is your f here? What is your f? It will be 1 over f, which is 2x plus 5, multiplied by f prime, which is 2x plus 5 prime, 2x plus 5 prime, 2x plus 5 prime. So if I simplify this, you have negative 1, is not writing here, negative 1, multiplied by ln 2x plus 5 to the power negative 2. And here 1, 2x plus 5. Now, what do you have in the middle? Plus. So you have to take the derivative of 2x prime plus 2x prime plus 5 prime. 5 prime. Because you have in the middle plus means you take the derivative term by term. So you have 2x prime plus 5 prime. What is 5 prime? What is the derivative of any constant? That's 0. What is the derivative of 2x? Just you get 2. You get 2. So what do you have? 2. From here 2. Multiply by negative 1, you get negative 2. Negative 1 here, multiply by 2. And the whole thing divided by 2x plus 5. 2x plus 5. Multiply by 2x plus 5 to the power, the whole thing to the power 1, negative 2. And that is our y prime, and you leave it like this. You leave it like this. So here, if some people say, can I apply quotient rule? Yes, you can apply quotient rule. It still be absolutely correct. Absolutely correct. Okay? So now, maybe I solve C and then I solve D because it's kind of related, right? So if I solve C, what is your C? Your C here is you have Y, that's number 4, right? So I'm just looking for C here. So what do you have for the other problem here? Okay, just go up here. So you have this one here, C. Maybe I copy and then I put it down so that I can solve it. All right, so here. All right, so here. All right, so here, that is the problem. I need to solve this. How to solve this one here? So I'm going to use law of log. What is that? If you have log A over B, what do you have? It will be log A minus log B. Why I have to simplify? Why I have to simplify? Because you have ln, that's log. I have to know the derivative of log. But here, what is inside? Oh, 1 divided by 2x plus 5. 1 divided by 2x plus 5, which means you have to use quotient rule. You have to use quotient rule. Quotient rule. Right? So what I have here, guys, so you will have log A minus log B. So you have ln 1 minus ln 2x plus 5, ln 1 minus ln 2x plus 5. So what is log 1? If I use technology, you get 0. Log 1 is here 0. That is make our life easier when I apply this law. Why? Because now here, up to here, if you apply the rule right away, you have to apply, the derivative of log, besides the derivative of quotient rule, because it's 1 divided by 2x plus 5. But here, when I use this one, now that is 0. When I use technology, then what did you get? You get negative 2x plus 5. How to take the derivative of this? It will be very easy. Why? It's just negative 2x plus 5. We have done that up, so I need to take the derivative of the whole thing. Negative 1, I can grab it outside of my derivative. So what do you have inside? 2x plus 5 prime. Right? So if I take the derivative of this one here, what do you have? You have negative 1, right? And then here is, what is your f? Oh, your f here is 2x plus 5, because the rule here is 1 over f multiplied by f prime. 1 over f, that is your f here, that is your f, it will be 1 over f prime. So now what is the derivative of 2x? 2. What is the derivative plus 5 here? It's a constant, it should be 0. So what did you get? You get negative 2 divided by 2x plus 5. 2x plus 5. So here, derivative of 2x is 2. 2 multiplied by negative 1, you get negative 2. Divided by 2x plus 5, right? So that is our y prime, right? If I solve the other one here, where is the other one? Just go up here so that I can copy this one here, right? I try to copy this one here, and then I solve this one. All right, so here, I need to take the derivative of this. Now, look what you have, guys, here. This one, whenever you have radical, always switch from radical to exponent. Switch from radical to exponent. So how to switch from radical to exponent? It will be ln 1 plus x squared, 1 minus x squared to the power what? To the power 1 over 4. Very good. It's 1 over 4. So you have outside 4. So the whole thing to the power 1 over 4. The whole thing to the power 1 over 4, right? Now, can I simplify? Let us use the law of log as much as we can, because that is 1 plus x squared divided by 1 minus x squared. That is what? Quotient rule. So you have a fraction, means you are going to use quotient rule, right? That's one thing. Also, you have, what is ln outside? Oh, that is the derivative of log. You have to know the derivative of log. And also, you have a bracket to the power n, which means you have to use power rules. So how many rules I'm going to use? Quotient rule, because you have a fraction, you have log, I have to use also log involved, and you have a bracket to the power n, which is power rules. So now, let us use law of log. Which one I'm going to use? I use as much as I can so that I can simplify. Instead of 3 rules, I could maybe use 1 or 2, not 3. So how? Look, let us recall, if you have log a to the power r, what is my r here? The exponent r, 1 over 4. So that it will be r log a, right? So I can put 1 over 4 in front. So you have 1 over 4 log here, 1 plus x squared, 1 minus x squared. And that is your y. Then when I put 1 over 4 in front, then I get rid of power rules. So now I get rid of power rules. So I'm not going to use power rules. Why? Because I don't have a bracket to the power n. Your n here become 1 just normal. So now we have a fraction. 1 plus x squared divided by 1 minus x squared. So what do you have? You have quotient rule, yes. So can I avoid quotient rule? Yes, you can. Which one? If you have log a over b, it will be log a minus log b. Log a minus log b, right? So now 1 over 4, it's outside. 1 over 4, that's a number. What is inside? What is your a? Your a here is 1 plus x squared. What is your b? So that is your b, 1 minus x squared. What is your a? 1 plus x squared. So you have ln 1 plus x squared minus 1 minus x squared. 1 plus x squared minus 1 minus x squared, that is your y. Now, I don't have a fraction. I don't have a fraction means no quotient rule. So you are very good. So avoid 2 rules. Avoid when I simplify like this. No power rule involved, no quotient rule involved. It's only log, which is I don't have any choice to, I have to use it. So now what is y prime? Y prime, I have to take the derivative of both sides. So you have ln 1 plus x squared minus 1 minus x squared. The whole thing prime. I have to take the derivative of both sides. 1 over 4, that's a constant. I can grab it outside, no problems, right? 1 over 4, that's a constant. I can grab it outside. So what you have inside, you have in between the two terms, one term here and another term here, between them minus. If you have in the middle plus or minus, then you take the derivative term by term. 1 plus x squared prime minus the derivative 1 minus x squared, 1 minus x squared prime. So I'm taking the derivative first term minus the derivative second term, because I'm in the middle minus. Then it will be easy here. Here is the rule. The derivative of ln f, ln, so I'm writing here, ln f. What is the derivative of this? it will be 1 over f multiplied by f prime. So here, what is your f? It will be y prime equal 1 over 4, right? What is your f here, guys? 1 plus x squared, 1 plus x squared. So what do you have? You have 1 plus x squared, that is your f. And then I have to multiply by 1 plus x squared prime. I have to multiply by 1 plus x squared prime. So that is the derivative of the first term here. Your f inside here, that is your f, right? It's not writing here, disappear right away. So you have 1 divided by 1 plus x squared multiplied by f prime. The second one minus, it's a big bracket here, minus, what is your f? Your f here is 1 minus x squared, and then I have to multiply by 1 minus x squared prime, right? So here is the rule here. So what is your f here? Your f here is, that is the one here. Your f is 1 minus x squared, so 1 over f prime. So now, just finish it. So what is y prime? Y prime, 1 over 4, right? 1 over 4, and then, just to give room myself, here 1 plus x squared. So now, what is the derivative of 1? What do you have in the middle? Plus, here, that's prime. Take the derivative of first term is 1. What is 1 prime? 0. What is the derivative of x squared? You have 2x. Minus 1 minus x squared. What is the derivative of 1? 0. What is the derivative of negative x squared? You have negative 2x. Right? You can leave it like this. You don't need to simplify. Just leave it like this. I'm happy. Right? Some people say, can I cancel 2? With, yes, you can. If you want to simplify, you can take 2 out. So you have here, instead of 4, I cancel 2 here. You cancel 2 here. So negative sign with negative sign. So you have here x divided by 1 plus x squared. Negative sign multiplied by negative sign here, you get positive. 1 over minus x squared. And you have here x, right? You have x. You can leave it like this, or up to here, I'm happy, right? So maybe some people can ask a question here. When I simplify, before I take the derivative, some people up to here, they say, oh, can I simplify log 1 plus x squared to log 1 plus log x squared? No. Here, rules, remark, let me write it as a remark. What is the remark here? The remark, if you have log a plus or minus b, that is not equal log a plus or minus log b. They are not the same. If you have in the middle plus, I cannot distribute. So here, log 1 plus x squared is not equal to log 1 plus log x squared. They are not the same. Simple example for this, if you take a equal 1, if you take b equal 1, for example, if I take a, like for example 1 plus 1, what is log 1 plus 1? Is this one equal to log 1 plus log 1? If I use technology, log 1, 0. Log 1, 0. So what did you get in here? 0 plus 0, you get 0. But what is log 2? You can use technology, you get some number. So non-zero number. You have a non-zero number, but here what did you get? You get 0. So what is the rule? If you have a plus or minus b, it does not equal log a plus or equal log b. I cannot distribute the log. All right? Please remember this remark because it's very important. Okay? So here, let me solve number 5 here. See this one here, that is related to the log. So you have b equal log base 2 q squared minus 3q, right? What is my base here? My base is 2. What is the question here? The question here is find dp by dq, the derivative of p with respect to q. Your p function in what? When I look to the right hand side, the right hand side is here is a function in q. So here your base is 2. So let me recall the formula here. Recall the formula. What is the formula here? If you have log base b of f, I need to take the derivative of this. Base b, what is your b? 2. And what is f? Whatever inside here, that is your f. Then here is the rule, 1 over f. You take whatever you have, ln b, your base, and multiply by f prime. What is f prime? The derivative, whatever inside your log. The derivative, whatever inside your log, right? All right, so now, if I go back here, db by dq, or you can write b prime, but keep in mind prime here, the derivative with respect to q. with there in the previous problems, I have the derivative prime means the derivative with respect to x. But here, because your function here, your p function in q, then I have to take the derivative with respect to q. So now, what is the derivative of this? It will be log base 2 of q square minus 3q. I have to take the derivative of this, right? So then it will be 1 over f. What is your f? Q square minus 3q log, which is ln b. What is b? Your b here is 2. And I have to multiply by the derivative of q square minus 3q prime derivative, right? So if I simplify this, you get 1 over q square minus 3q ln 2. And what is the derivative of q square is 2q. What is the derivative of minus 3q? It's only minus 3. Just leave it like this. Just leave it as 2q minus 3 divided by this one, the whole thing divided by q square minus 3q multiplied by ln 2, right? ln 2, and then that is the one you should really leave it like this, okay? And here they are to give you q greater than or equals 3. That is the domain of your log, you right? But I'm not going to just, that is defined. There is a condition q must be greater than or equal 3, which is okay. So that is not related to our derivative, but that is related to the domain. That is the domain of the functions. Okay, guys? So let me solve here some of this problem here. Maybe I solve this one, last one here, right? If I solve this one here, and then we'll see what else we can solve. This one here, it's a combination between product rule and quotient rule. Right, so maybe, and this one here is what is a quotient rule, that is product rule and quotient rule. So let me solve one by one. So let me solve maybe I solve the first one. All right, so what do you have? You have y equal x ln, I cannot see here, x to the power 2 plus 2, right? X squared plus 2, or maybe x squared plus e, so I cannot see here, but it's okay, x ln x squared. How to take the derivative of this? Just read it loud. X multiply by ln x squared plus 2. So when you say multiply by, means product rule. What is product rule? Fg prime. It will be f prime. F multiplied by g prime. That is product rule. Plus f prime g. F prime g. So what is your f? If I try to apply, that is your f. The first one. The second one, g. So y prime, if I try to apply product rule, here, so what do you have? If I try to apply product rule, just to try to, your x, it will be your f, just your x, f, and ln x squared plus 2, that is your g. So I'm taking the derivative. So that is your f, and that is your g prime, plus f prime, which is x prime. G, what is g? ln x squared plus 2. So that is your f prime, and that is your g. That is product rule. Then I have to finish it. X, what is the derivative of log or ln x squared plus 2? It's 1 over x squared plus 2. That is my f here for the rule of the derivative of log. Excuse me. So I have to multiply by x squared plus 2 prime. And here, what is x prime? X prime is what? Is 1. X prime is what? Is 1. So multiply by x squared plus 2. And then I have to finish what is the derivative of x squared plus 2. X squared plus 2. Then you are done. So here x squared plus 2. What is the derivative of x squared? 2x. X squared 2x. What is plus 2? 0. And then you have ln x squared plus 2. ln multiplied by x squared. That is ln x squared plus 2. That's one term. 2x multiplied by x. If you want to simplify, you get 2x squared over x squared plus 2. And here plus ln x squared plus 2. Then you are done here. So that is kind of product rule. Product rule. How did I figure out product rule? Just if you hear yourself, oh, x multiply, when you see multiply, product rule. The other one, when you say quotient rule, E, this one here, E, what do you have? You have, just let me, G here. You have ln. So you have g of x equal, right? G of x, maybe I copied the problem here. That is E. G of x, ln x plus x So ln x plus x divided by square root of x, right? So that is ln x, right? So that is e problem here. I need to take the derivative of this. So what did you have here, guys? You have what's called here, you have ln, that's one term, divided by square root of x. So that is quotient rule. You can apply quotient rule. Some other guys, he say, can I simplify this as ln x plus x over x to the power 1 over 2? This one I can write it x to the power 1 over 2. Yes. And then you can apply quotient rule, or you can take this one here up, then you apply product rule, right? So what I'm saying here, so some people say, can I take the 1 over a to the power n? What is that? It will be a to the power negative n. So now this one, I could write it as ln x plus x to the power. When I take this one here up, what do you have? You have x to the power negative 1 over 2. What is your exponent? 1 over 2. When I take that up, become negative 1 over 2. Now, what do you have? You have a bracket, which is ln x plus x multiplied by x to the power negative 1 over 2, which is here product rule, right? Product rule. You can do that. What is the product rule here? FG. So that is your f. So what is the product rule? It will be fg prime plus f prime g, right? So what is the f? It will be ln x plus x. That's one term. G prime. What is g prime? X to the power negative 1 over 2 prime plus the derivative of f prime. That is your f prime, and multiply by f here. F multiply. That is your fg. So that is f prime g. F prime. That is f prime g. And that is your fg prime. And then go ahead and take the derivative. What is the derivative of this? That is your y prime or g prime, right? So that is, it will be g prime, right? G prime, that is the derivative equal to this. So now let us finish it. ln x plus x, right? What is the derivative of that shortcut formula? Negative 1 over 2, that is your n. X to the power negative 1 over 2 minus n. So n minus 1. And here, what you have in the middle, the middle here plus means you take the derivative of the first term plus the derivative of first term plus the derivative of second term. So what is the first term? ln x prime plus the derivative of second term, which is x prime. I close the bracket. This term here exactly the same. I'm just copy like this. And that is equal. So let me simplify. So you have ln x plus x, that is the one term here, and this one negative 1 over 2, x to the power negative 3 over 2. Negative 1 over 2 minus 1, you get negative 1.5, which is, or negative 3 over 2. Close the bracket. ln x, what is ln x? 1 over x multiplied by x prime. 1 over x multiplied by x. So here ln x, what is your f? 1 over f prime. 1 over f prime plus x prime. What is x prime? X prime is 1. I have to write 1. Multiply by x to the power negative 1 over 2. What is x prime here, guys? Your x prime is 1. So just copy this. It will be just ln x plus x, right? And here, negative 1 over 2, x negative 3 over 2. And here, just 1 over x plus 1. And x to the power negative 1 over 2. So x prime is 1. So I copy right just 1. You leave it like this. You don't need to simplify anything. Just leave it like this. All right? So that is here. Some people say, can I use quotient rule here? Yes, it's correct. Also, if you use quotient rule, absolutely correct. Right? So here, either it's mathematics, right? So you can use your own way to do it. And at the end, it will be correct. All right? So let me solve this one here, the last one here. And then I closed my lectures here. So this one here, how to solve this one here. I need to just read it so that you can know how we are going to use, right? Which one I'm going to, ln x multiplied by square root of 1 minus 2x. So here, whenever you have radical or square root, just write it, switch to exponent. So ln x, here x multiplied by 1 minus 2x to the power 1 over 2, to the power 1 over 2, right? So you have x multiplied by a bracket to the power 1 over 2. Now you have x multiplied by, that's a product rule. you have a bracket to the power n, that is power rules. So here I'm going to use law of log. What is the first one? I'm going to use log A multiplied by B. It will be log A plus log B, right? So here it will be ln x, that's the first term, that is your A. So your A here is x. What is the second term? B. So it will be plus second term, which is minus 2x to the power 1/2. So that is here. I break that down, x. So now I don't need to use product rule, because here you have x multiplied by product rule. So I don't have, but here you have a bracket to the power n. So that is called here power rules. But here, if I use this rule of log, if you have a to the power r, then I can put r in front. Then you have log a. So this one, it will be your function here is ln x. 1/2, I put it in front. Then you have ln 1 minus 2x. So now I don't need to use power rules because I don't have a bracket to the power n. All right. So now I take the derivative of this. You have ln x plus 1/2 ln 1 minus 2x. I have to take the derivative of the whole thing. What do you have in the middle? Plus. Then I have to take the derivative of first term plus the derivative of the second term. The derivative of the second term. So what is ln x? Ln x here will be 1/x. 1/x multiplied by x prime. And here you have 1/2. That's a constant. I can grab it outside. So what do you have left? ln 1 minus 2x. What is your f? That is your f. It will be 1 minus 2x multiplied by 1 minus 2x prime. 1/f, f prime. What is x prime, guys? X prime is 1. X prime here is 1. And here 1/2, that's a constant. Here you have 1 minus 2x. What do you have in the middle? Minus. What is the derivative of 1? Constant, 0. What is the derivative of negative 2x? Just negative 2. What is the derivative of negative 2x? You can grab negative 2 out. What do you have left? X prime, which is 1. So you can leave it like this. I'm happy. Or some people, can I cancel 2 with 2? Yes, you can. But what do you have in the middle? What do you have in the middle? You have in the middle here. So you have 1/x. 1/x here. 2 cancel with 2, but you have negative sign. And here plus. Negative with plus, you have negative sign coming out. And here 1/1 minus 2x. 1 minus 2x. You leave it like this. You leave it like this. So here again, you have in the middle plus. Here you have negative sign. Negative times positive, you get negative. And here you have 2 cancel with 2. 2 here cancel with 2, you get negative 1. So negative 1 multiplied by positive here, you get negative sign in the middle. And that's what we have for our log. All right. I think I will stop here, guys. That is a very good example about how to take the derivative of log. Sometimes it's required to simplify, make our life easier if you simplify as much as you can before you take the derivative. However, if you don't simplify and you apply the rule correct, okay, it will be correct. Okay? All right, thank you. You have a good one.